Well, we have now come to the part of the chapter where we are going to be looking at some quadrilateral proofs. For this, I am going to introduce you to the idea of a two-column proof, which you kind of have already seen in some of the homeworks. And we'll be practicing proof when we're in person. So again, hopefully you will have seen this before now. But if not, I'll be there to help you. As we prove things, we have to remember that we can't use the conjecture to prove itself. This is called circular reasoning. And so we have to really ask ourselves, like, what am I trying to prove and what steps I'm going to take to get there? And of course, we're going to be using our triangle congruent shortcuts because all of these quadrilateral proofs have their basis in that. For this first problem, we are going to prove that the opposite angles of a parallelogram are congruent. And so for this one, we are just going to work on angle HBA. So this is angle HBA here. And we are going to show that that is congruent to angle ATH, which is this angle here. If you were going to do a very rigorous proof, you would have to show this holds true for both sets of opposite angles. But for now, we're just going to suffice to start at one. What are we given? We are given parallelogram BATH with diagonals BT and HA. We are also able to use any other properties or conjectures that we know about parallelograms, except for, again, the one that we're trying to show. So we couldn't, for example, say that angle H was congruent to angle A within this proof because that is technically part of the proof, even though those aren't the two angles we want to show are congruent. But we can forever, for instance, remember that the opposite sides of a parallelogram are parallel. That's what makes it a parallelogram. The opposite sides are congruent. We could use that in our proof. We could use the fact that the diagonals bisect each other in our proof, anything that we might think is useful. But we also want to, we don't want to overly complicate it. When we write a proof, the goal is to be as concise as possible, but also as rigorous as possible. And so sometimes mathematicians call a proof elegant. An elegant proof has as few steps as possible. So elegance is important. Again, let's think about our triangle congruent shortcuts. We are trying to show that angle B is congruent to angle T. Now, I'm going to erase some of these marks here, but I want you to remember that they're there because we're going to use them. So I'm going to ask myself, what triangles contain these angles? And if I see there's this triangle here and this triangle here. I'm trying to pick up a new color. And so those are going to be the triangles that we're going to use for our proof. With a two-column proof, we put the statement on this side and the reason on the other. If you like a flowchart proof, you can absolutely do that. If you like a paragraph proof, you can absolutely do that. So again, my first statement is just to say that I have parallelogram BATH, diagonals BT and HA. If I was given more detail about the diagonals, I might write it as a separate step, but this is just kind of acknowledging their existence. So I'm going to just go ahead and put it in the same step. All right, so we've got our triangles. We want to show that they're congruent. There are a couple different ways we can do this. I'm thinking side, 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 but you could also use possibly a angle side angle if you want to go the parallel, if you want to use alternate interior angles. But I think side, side, side is actually a pretty nice, efficient way to do this one. So let's think about what sides do we have? Well, we know that BH is congruent to TA, and that is the parallelogram opposite sides conjecture, but you could just say the opposite sides of a parallelogram are congruent. So you can just say that. Opposite sides And so we have this segment congruent to this segment. And then guess what? Let's do that same thing. Let's, with the other sides, this is step 3, we're going to say that segment BA is congruent to segment TH. Notice how I'm being very careful to work with my correspondence. So again, if I go B to H, I went T to A. I'm going B to A, I go T to H. That's very important. And just to prevent myself from having to write that all again, I'm just going to put the 2 little hash marks, which mean, you know, repeat what was above. And now we know that segment HA is congruent to itself because of the reflexive property of congruence. That's what the Big Ideas online book is using, but you could also just say same segment, shared side. Again, that's the reflexive property. All right, here it is. Our triangles are congruent. So what triangle? Let's call this HBA. And then if we go HBA, we're going to go ATH. And that's by side, side, side. And then finally, we can say that angle HBA is congruent to angle ATH by our favorite thing, CPCTC. Nice job. All right, let's look at this second one. I like this because here we're actually proving something is a parallelogram. So I'm not telling you it's a parallelogram. I want you to show me that it is with these given conditions. And it's kind of interesting because there is a whole idea of what minimum conditions do you need to show something as a parallelogram. Thinking about like what would the minimum conditions needed to show triangles are congruent, we can kind of take a different direction and ask ourselves, what minimum conditions do we need to prove a certain shape has, you know, properties of like a parallelogram or a kite or a trapezoid or something like that. So in this case, we can show that something is a parallelogram by just having a pair of opposite sides being congruent and parallel, because that is what we have here. So let's go ahead and start that off. Again, we're trying to show it's a parallel. Oh, let me back up 1 second. What does it mean to show something as a parallelogram? What is the definition of a parallelogram? Well, it's a quadrilateral with 2 sets of parallel sides. So what are we ultimately trying to show here? We need to show that PA, segment PA, is parallel to segment SO. That is what we are trying to show. So that's our want to show. That is the step before we can say something is a parallelogram. We want to show it's a parallelogram, but I kind of sometimes think about the step right before that. Statement, reason, so this is when I'm going to put this in 2 different lines. We're just going to say quadrilateral SOAP with SP parallel to OA given, and then I'm going to say SP is congruent to OA given. So at this point, I don't have a lot to go on. I have this diagonal segment here. I have segment PO, and I do think I want to get some triangles congruent, but I can't use side, side, side like I did up above. The reason why I can't do that is because I don't have any sort of special quadrilateral right now, so I cannot definitively say that PA and SO are congruent. They look congruent, but it doesn't mean that they are. I do have a set of parallel lines though, and anytime I see parallel lines, I basically formed it in our picture. Here it is, our Z, our alternate interior angles. Those are very important. I really want to try to pick up a new pen color, but I don't know if I'm going to be able to. Let me adjust this a little bit. Okay, So this angle here is going to be congruent to this angle here. Now I've already established I have a parallel line, so I don't need to restate that. But now what I can say, if you want to go ahead and call it angle SPO or just call it angle 1, how they've labeled it in the diagram, we can say angle 1 is congruent to angle 2, and that reason again is the alternate interior angle conjecture, or we can just say AIA. All right, so I've got a side, I've got an angle. I'm thinking side angle side. I could I do side angle angle? I'm actually asking myself that question right now. Could I do side angle angle? I don't think I can. The only way to get 3 congruent to 4 would be if these were my sets of parallel lines, and we don't know that's true. Okay, side angle side it is. So once again, we can say that PO is congruent to itself. And finally, or not finally, excuse me, but next we can say that triangle SPO is congruent to, so again, SPO, I have to call this AOP. Side angle side. Then I'm going to establish that angle 3 is congruent to angle 4. Watch this. This is great. So we can say angle 3 is congruent to angle 4. That is by CPCTC. Okay, can you see where we're going? So in a couple steps before this, remember I said we can't say 3 is congruent to 4 because we don't have parallel lines, but now we know 3 is congruent to 4 by CPCTC. So what does that imply? That implies that PA is parallel to SO. If my alternate interior angles are congruent, then my lines are parallel. Now, what do I call this? I call this converse of AIA. I can't call it AIA. That says if the lines are parallel, then the angles are congruent. The converse says if the angles are congruent, then the lines are parallel. We're almost there. We got our segments to be parallel, but we technically haven't finished the proof until we have SOAP is a parallelogram. And that is by definition of parallelogram. All right, I know these proofs weren't easy. I know they have a lot more steps than when we just had some basic triangle congruent shortcuts. So I'm so proud of you for following along, sticking with it, and great job.